Hey everybody, welcome to Mammoth Interactive's YouTube channel. First of all, I want to thank you for watching this video. And remember that this channel doesn't do Patreon. Instead, we sell our digital courses down below. And every single dollar that we get from the products you buy below goes into making more content. The best way to help out this channel and Mammoth Interactive is to subscribe to Mammoth Interactive's huge library of content. Get thousands of hours and hundreds of courses for a low price down below. We have a monthly option and a yearly option. Thanks for listening, and I'll see you in the video.
Hello everyone, and welcome to our course. In this course, you're going to learn how to build two chatbots with two different techniques in Python. We're also going to use popular libraries for data science and machine learning, known as Pandas, Numpy, and Scikit-Learn. So let me preview for you the two projects in this lecture, starting with our first chatbot. So we can ask it questions like you can say hi, and we'll get this result of an answer. Hello, please ask me a question. We could also make this an infinite loop just by removing this break statement, then rerunning this code cell, and now I can say hello, and I can keep chatting to my chatbot. So we will get an answer to any question we ask, such as, when does this expire? And we can see here we get a bunch of data that I've included that we will understand what it means as we go through the project, and we get as well an answer. You can ask another question like, is this course live? And look at that, we get another answer. Now for this first project, we're going to be using a frequently asked questions CSV file, so a spreadsheet that I've created where we have a question and an answer for every question, and this will be provided for you. This is going to be the technique for building out this first chatbot. So we're actually going to use a frequently asked questions data set. We're going to learn how we can take this data set and use Pandas to convert it to a data frame. We're also going to learn how we can train a vectorizer, because we have to take this English text and we have to vectorize it. So we're going to use the Scikit-Learn library to extract features from this text and turn this text into vectors. We're also going to use Numpy to help with that, because in order for an algorithm to understand English, we have to be able to convert the language data to a numerical representation, because computers can't read, but they can understand words and vectorizations of words. So if you create a vector out of a word, you can then plot it on a graph, and you can then plot all types of words on the same graph, and the words that have a similar stem or a similar meaning, they will end up closer on the graph. And so that is how you can teach a computer to read, by plotting words on a graph. All right, and then next up, project 2, we're going to build another chatbot. So again, I can type in something like hi, and I can ask common questions. For these projects, I'm using common questions that our company gets, so it's a real world scenario. And of course, I'm going to show you how you can extend it to be answering any kinds of questions that you might want to handle for your company or your project. So we can ask questions like, let's see, is this live or can it be revisited? All right, as well as, how will I access this? And look at that, we get all of these answers. So for this second project, it's going to be a different format. We're not going to be actually using a frequently asked questions spreadsheet. We're instead going to build our second chatbot just by creating a list of common intents that our chatbot will be familiar with, and then generating an answer for that intent. So it's going to be a slightly different technique for building this chatbot. We're going to teach our chatbot how we can recognize an intent of a question, like, is this a greeting? Is it a question about a refund? Is it a question about revisiting a site or accessing, etc.? I'm very excited to show you these projects. There are so many techniques for building chatbots, and we're just going to be showing you two of them in this course. This course is going to be completely beginner friendly. We will include for you a section on Python in case you've never programmed in Python before. So do take that section if you don't know Python. If you do know Python, then just skip the prerequisite and go straight into the first chatbot project. Now, these are just two techniques for building chatbots. As mentioned, there are so many of them. You could use artificial intelligence, you could use machine learning, you could use just basic algorithms, you could even just use the spreadsheet technique. There are so many different techniques out there, and chatbots are really fun to play with. Chatbots have not even been perfected yet, so it's an open field. There's a lot more work that can be done with chatbots. It's hard to build a perfect chatbot, but it's easy to build a chatbot that works for you. All right, so let's get started. Join me coming up in our next lecture. Hello everyone, and welcome back to our course. In this lecture, we're going to do a quick overview of what is natural language processing. This is a huge field, both in data science and machine learning. And so we're going to do a quick introduction to that as just a bit of theory before later on we jump into coding our projects. All right, so natural language processing, also known as NLP. This extracts insights from textual data. For example, customer emails or tweets or messages. All of that is considered textual data. There's so much textual data out there because, the internet has provided such an increase in data, and there's so much that you could collect for your company or just for your research or for anything, for your own interests, for entertainment, for publishing, for making videos. There's so much text data out there, and that's a lot of potential that you can use to get really big insights. In fact, natural language processing has been used to provide huge insights. For example, even from tweets, you can provide information about what people are feeling about a certain topic. You can even predict their behavior. For example, Google can predict when a flu will come based on what people are searching. All of that is getting insights from textual data. For example, if people are searching how to get a certain, flu or cold medicine, then Google can actually predict that means that area of where those people are searching that is going to have a surge in a potential outbreak of the cold or flu. As well, customer emails, you can get information from your customers about what they're commonly asking you. You can also build a chatbot to quickly respond to that. And just any messages you get or any text out there. A lot of data is in the form of text. Even medical records are often in the form of text. And it's a lot of tedious work to have to go through that manually by hand. But with the help of computers, we can get information at a speed that would be impossible for a human to get. A lot of data out there is in the form of text. So this is a very important field and topic to know about. Even if you don't want to be a specialist in natural language processing, just knowing about it is going to be useful for really any kind of project that you're building and that you're doing at work or, for fun or for a side hustle. Any of that is going to often use natural language processing. It's very commonly used for all sorts of projects. So it's quite important to learn about, and I'm glad that you found this course to get your first introduction to it, because we're going to provide a beginner's introduction to natural language processing. All right, and the goal is that this course can be great for anyone to understand. So NLP powers many applications like chatbots, translation apps, and document summaries. NLP, natural language processing, can even create text. It can be used to write books and write blogs. It can be used to summarize news articles. The power of these types of applications are huge, and lots of applications have been sold for a lot of money that use natural language processing. For example, apps to summarize news articles. That's a big one that uses NLP. It was very, very popular and sold very well. So it's a very huge and lucrative field. Lots of companies need NLP for all sorts of different problems they have, like understanding how customers are feeling, getting customer reviews, analyzing their sentiment, seeing how did customers like this movie or this restaurant, as well as building chatbots to quickly handle customer feedback, and being able to respond to customers at a lightning speed. It saves a lot of time and money for companies to implement natural language processing. So we are going to use natural language processing to analyze natural language text and deduce its language-specific metadata. That is really the goal of NLP. You want to be able to understand a specific language in a piece of text, whether that be English or any other language. There are different components to natural language processing, so let me introduce some. There's language identification, which is being able to detect the language of a piece of text. There's tokenization, or splitting text into linguistic units or tokens. There's named entity recognition, where you identify tokens as names of people, places, or companies. And furthermore, there's part of speech tagging. You can find, is this a noun, a verb, an adverb, an adjective? You can also lemmatize words, so determine a word's stem based on its morphological analysis. For example, the stem of running is run. And there's so much more. These are just a few examples of what natural language processing can do. The power is quite impressive. Teaching a computer how to read and how to understand words is a really big feat, and it's still an open field. Machine learning, artificial intelligence, data science, they're still relatively new compared to other fields, so there's still a lot to be made. And it's very impressive because there have been so many kinds of applications. Just off the top of my head, there have been applications to, recreate Shakespeare plays and create new ones that a computer has done. So a computer just reads a bunch of Shakespeare and then it creates its own Shakespeare play. That's just one very simple example. And that is an introduction to natural language processing. Coming up, we're going to do a little bit more theory, and then we'll jump straight into building our first project together. It's quite an exciting and fun project, so join me coming up in our next lecture. Hello everyone, and welcome back to our course. In this lecture, we're going to do a bit of theory before we jump into our project. And the theory is we're going to learn what is text vectorization. So we're going to have a better understanding of what does it mean to take text and turn it into a format that a computer can understand. All right, so let's talk about the problem that we have. How do we teach computers to read? A computer can't understand English or another language. It doesn't read like we do. How do we teach computers to make sense out of strings of text? Well, the solution for that is what we're covering in this lecture. We have to turn text into a numerical representation because computers and algorithms, they can understand numbers and vectors, arrays, lists, but they can't understand, strings of text in terms of making sense out of them. But computers are very good at making sense out of numbers. So we have to find a way to turn text and words into numbers. So let's think about how we could do that. Well, we know intuitively that some words are similar to each other because they have the same stem. For example, dog and dogs, those two words are very similar to each other. They have common letters, okay? As well, dog and wolf. Now, those are not similar to each other in terms of stem, but they are similar to each other in terms of meaning because a dog and a wolf, they're both animals and canines. So how do we tell a computer that a dog is similar to a wolf? Well, there's also something known as context that comes into play. If dog and wolf appear in the same context over and over again, being used in very similar ways, then that also tells us that they have similar meaning and that they should be more closely represented and that they should be understood to be similar things. Because dog is much closer to wolf than dog is to a word like imagination. All right, so let's talk more about word embedding. Word embedding is a text distribution representation. It means that words with similar meanings have similar representation. So this is what we have to try to achieve. We have to teach a computer that words have similar meanings, not just if they have the same stem, like run and running, but that if they have a similar meaning as well, that means that they should have a similar numerical representation. So how do we teach a computer that running and jogging are similar to each other? Well, let's jump into that. What we do is we can actually turn a word into a coordinate on a graph. And these coordinates, X and Y, they take the numerical representation of a word and they allow you to plot it on a graph. And you take things like stem into account, you take things like context into account to plot the word on a graph. And then words that are similar to each other in terms of meaning, they'll be closer to each other on the graph. So girl, woman, and daughter, those will be closer to each other on the graph. Boy, man, and son, those would be slightly farther away, but they still are all people and nouns, whereas USA, New York, and USD, those would be close to each other because they have similar meaning, similar association as well. So we have to take all that into account. It is a complex task, natural language processing, being able to take natural language and process it into a numerical representation that isn't just arbitrary and doesn't just go off of stem or letters, but actually that uses context into account where the word has appeared previously. So it's a big task. So first, we have to convert strings to numbers. So that's known as vectorization, where we turn a string into a vector. So this could be an array, this could be a single number. Typically, it's going to be an array for a more complex representation. Then we can feed that vectorized representation into a model, and the model is going to, for us, put it on a graph and be able to make sense out of it. Now, for us, we can abstract away a lot of the hard work to libraries like Scikit-Learn, which have these models pre-built for us. Of course, you could build these models yourself to make sense out of words, but that is much more complex. So for a beginner, these libraries like Scikit-Learn, they're very helpful for you because they provide these pre-built models that can make sense out of vectorized strings and put them onto graphs and be able to tell you which words have similar meanings. Let's look at a really simple example. Let's say we have 3 words, puppy, dog, and cat, and we're trying to make sense out of these words. Well, first we would vectorize the words. So we would take puppy, dog, and cat, and we would turn them into a vector. Now, let's look at the vectorized representations. Here I've used colors as a visual example of a vector, but really it would be numbers, it would be floats. And each color here represents a different number, let's say, because a vector is going to be a list of numbers to represent the word. Now you can see here, puppy, dog, and cat, they all share a yellow color, which means that they all share one number in their vectorized representation. So why do they share the yellow? Well, this could be for a whole number of reasons. I mean, they're all animals, they're all nouns. That could all be a reason that they all share the one color. But note here, puppy and dog at index 0, they have a green color, but cat at index 0, that first color, cat has white. So that is a difference. And that could be likely that puppy and dog are both canines, whereas cat is feline. So you can have this specific index that represents that specific meaning of what type of animal, canine or feline. At that index, puppy and dog have the same exact color or number, but cat has a different color or number. And that is one differentiation. That's one way to differentiate between the words. Now look at the last index. Puppy has blue and dog and cat have red. So this index is a different branch of meaning. For example, it could be that puppy is a small animal, but dog and cat are a bigger animal. Puppy, it would be younger, dog, cat would be older, So that could be why we have blue for puppy and red for dog and cat. So again, a different index in the vectorized representation, and it represents a different branch of meaning. So that's just a simple example of how we can differentiate between words. Here's a little bit more of a complex, realistic example. So typically you wouldn't have just 3 indices. You would actually have a lot more indices to represent words because words are really complex. They can mean a lot of different things. There's a lot of context you have to take into account. There's a lot of different relationships between words, like is it a noun, is it a verb, is it an animal, is it a young animal, is it a person, is it even a physical noun, or is it more of an abstract noun like imagination or dream, stuff like that. And that is text vectorization. You're going to have a lot more exposure to text vectorization when we jump into our project. So join me coming up in our next section. Hello everyone, and welcome back to our course. In this lecture, we're starting a brand new section where we're going to learn how to build a chatbot from frequently asked questions. So for that, we're first going to have to load in our data set of frequently asked questions. Then we're going to train a vectorizer and then chat with the user. All right, so here is our data set. Okay, I have it open here in Google Sheets. You can also open it in Excel or another software that allows you to work with CSV files. All right, I've included this file for you as well. You can find it at the end of this section. It's called frequently asked questions.csv. It's in the source files. You can see here we have a small data set where one column is a question and the second column is the answer. And I can format this and text wrapping. I can wrap all the text so you can read each question and answer. And then I can expand this column to make it a bit longer. Okay, so you can see here we have the question and the answer, and we only have 10 questions here. And that's a relatively small data set. Typically with frequently asked questions, you would have a whole bunch of questions that you frequently get to your company. So I've used the most common questions that we get at our company and put them here. All right, but of course you could definitely add more here to increase the accuracy and capabilities of your chatbot. but I've started with just this small data set, so it'll be really easy for us to understand what's going on in the project. So make sure you have downloaded that CSV file from our source files at the end of the section. You can also just create your own CSV file. All you have to do is have a column of questions and a column of answers. Make sure you also have the header as the first row that says question and then answer. All right, awesome. So that is our data set. Now, let's go to this website, colab.research.google.com. This is a free online code editor, and this is where we're going to actually build our project. All right, so the first steps first, we have to take that CSV file and bring it into this project. So for that, I'm going to import from google.colab the files module. This will allow me to upload a file into this Google Colab. So I'm going to call files.upload, which is going to prompt me to upload a file to this Colab. Let's just give it a minute because it has to initialize the Colab. Okay, and then I can click choose files, and a pop-up will appear that will prompt me to select my CSV file. All right, and I'm going to grab that frequently asked questions.csv. And then look at that, it will be saved to frequently asked questions.csv, and we also get a preview of its contents. All right, next, let's take that CSV file and let's convert it into a Pandas data frame. So I'm going to make another code cell, and I'm going to use the Pandas library. So I do have to import Pandas if I want to use it. It's a very commonly used library because it allows you to create a data frame out of your source files, whether that be a CSV or a text file or a JSON data. You can turn it into a Pandas data frame. So I'm going to use the Pandas library, and I'm going to use its function read CSV. Then, because I uploaded the CSV file to this Colab, I can actually just refer to that CSV file by its name, and the Colab will know that it exists. But note that if you close this Colab and come back to it, you'll have to re-upload the file. All right, and we're going to save this as our data frame. Okay, then we can now print out the data frame to see its contents. So I'm going to run this code cell, and look at that. First, we have a column which represents the index of each entry. We have the question and answer, that first row that doesn't even have an index because it's just the header. The first row of your CSV file will always be considered the labels of the columns. Then we have a preview of all the contents. All right. Okay, it looks like we have actually 9 entries. We can also drop all of the null values from our data frame. If we had null values, we could call dataframe.dropNA in place equals true. So if we had any null values, we would drop them. That's a very useful function. So in case you're using your own data set that you've created or that you've found on the web, I'm going to show you that it's very useful to use this drop NA function. Just do a bit of cleaning. All right, next step, let's actually train a vectorizer. So I'm going to make another code cell, and we are going to have to import the TF-IDF vectorizer. This comes from the library Scikit-Learn, SK-Learn for short. Scikit-Learn is a very popular library for data science and machine learning because it provides a whole range of modules and classes for building out your projects really quickly. So I'm going to go into the sub-library feature extraction.txt. This is a specific sub-library for extracting features from text data. And we're going to import the class TF-IDF vectorizer. Just make sure you spell it exactly correctly. TF-IDF vectorizer, and make sure you capitalize it exactly the same as well. This is going to allow us to vectorize our text, so we can take these questions and these answers, and instead of just having them be English or whatever language you have, we are going to turn them into a vectorized representation, meaning a numerical representation that algorithms and computers can understand, as well as machine learning models. And that's what we're doing with the help of TF-IDF Vectorizer. All right, so I'm going to then create a new instance of that vectorizer. So I'm going to just create a new object from the class, and I'm going to store this as my vectorizer. Then I'm going to call my vectorizer and use the fit function on it. This will take my vectorizer and fit it through my data, meaning I'm going to vectorize my data. Now, what is the data that I'm vectorizing? Well, I'm actually going to use NumPy, and I'm going to use the concatenate function. I'm going to concatenate here my dataframe.question with my dataframe.answer. So let's break this down. First, we're using the Numpy library. So we actually do have to import Numpy as well. The third library we're putting to use here. Numpy is a very popular library because for many reasons. It provides tools for scientific computing. It also provides the Numpy array type, which is what we're using here. So the Numpy array type, it takes a regular Python list or a data frame dot question, meaning we're taking that column only of that data frame, and it wraps it in the Numpy array type, meaning it's an array, yes, but it also allows for a whole new range of functions, and it's also a lot faster in terms of computation and processing. So Numpy is very, very commonly used. Okay, so what we're doing here is we're taking the question column from our data frame right here, and then we're taking the answer column from that data frame as well, and we can just access them with that dot question dot answer. And we're concatenating the two and returning those into a Numpy array. That's because this vectorizer, for the fit function, it's required to take a Numpy array as its argument. We can't pass in the data frame. All right, and that is going to vectorize all of that data. Then I can grab my vectorizer and I can vectorize the questions. So first this is going to just train the vectorizer on the data, then we can actually vectorize the questions with the transform function. And I'm going to pass in dataframe.question. The result is going to be vectorized questions. And then if I print out the result, we can see what we get of vectorized questions. I'm going to run this code cell and look at that. Now we have this list of elements, and you may be wondering, what is this? Well, these are actually all of our questions, but vectorized, so converted to numerical representations. We could also do the same for our answers as needed. All right, that does it for this lecture. Coming up next, we're going to continue the project, and we are going to actually start chatting with the user. That's right. We are already ready to start chatting with the user. All we had to do was load in our frequently asked questions and then vectorize those questions. So join me in the next lecture where we are going to show the chatbot.
Hey everyone, thanks for watching this course. If you want to watch the rest of the course, the link is down below. Not only will you get the access to this course, but you'll get access to a lot of other courses in a huge bundle, and it's on sale today. So buy before the sale ends. Thanks for watching, and I'll see you in another video.